while both multi-layer packing and advanced protector usage for malware has definitely complicated things for anti-malware companies for a while. Eventually, one way or another, most of the companies kind of figure out strategies against both, which works. I mean, of course, easiest ways for both of them is just detection. So it's kind of almost like a giving up strategy. If your antivirus engine cannot unpack multiple layers and cannot unpack advanced protectors, just detect it as a suspicious thing. And this actually created, in case of multi-layer packing, that was not a big of a deal, because most of the time if you see more than 2 or 3 layers of packing, you can just assume it's malware. So statistically speaking, that was a very big weakness of that approach. And at some point, most of the antivirus companies kind of stop even trying to unpack all the layers and just say, okay, if they're more than 3, 4, 5, just detect it, whatever. So that works quite well for multi-layer packing. While advanced protectors created a serious issues that benign software which were using those advanced protectors to actually protect itself from crackers and pirates were disproportionately affected by poor antivirus engines, which would simply detect everything packed with a certain packer as suspicious. And this has ended up with the two results. One is some protectors just went out of business. Especially small protectors, they couldn't just convince antivirus companies, they sometimes wouldn't even hear them, to not detect them and to convince them they're not malware. And they would just run out of business because legitimate software would stop using them. But they're not only bad, but also good results. It was significantly improved the advanced protectors would significantly improve licensing schemas. And what they would do, they would provide a list of abused license keys to major antivirus engines. So to prevent detection just by being a protector, most of the protectors would have a licensing key embedded in them. And what would happen is, of course, the protector authors would not want to sell the product to malware authors, but sometimes either the key would leak or the protector would be pirated, so it actually works without a key. In this case, advanced protector developers would collaborate with antivirus industry and would provide a blacklisted abused license keys, or provide details on how to detect incorrect cracked version of their protector. And that significantly improved licensing, even though I still think that antivirus industry inflicted a lot of pain to industry of advanced protectors, which was not necessarily a good thing, just because antivirus industry couldn't resolve that problem of how to unpack advanced protector. And of course, a lot of engines also just learn how to unpack multiple layer packing. And even some protectors, some more advanced antivirus engines were able to unpack some of the protectors either statically or dynamically eventually. And since antivirus industry kind of figure out both multi-layer and advanced protectors, of course, malware authors came up with the even better approach. And that approach called server-side polymorphism, and this was approach which exponentially grew a number of malware variants, and let's talk about this, how and why it happened. Remember in previous episode when we talk about polymorphic viruses, I explained you that most of the polymorphic viruses would infect the entry point of the binary, and then they would have polymorphic decryptor and then encrypted body of the malware, but the virus itself would be encrypted and hidden inside the binary. So this concept, while it was pretty advanced, right, the entry point would be hijacked, the virus would go to decryptor would decrypt and then unpack and load the malicious payload and execute it. It was very, sometimes very sophisticated viruses. And for some time, that kind of polymorphic virus technology were not accessible to like a regular everyday malware developers, right? But at some point, there were enough knowledge about polymorphic viruses, and source code of existing polymorphic engines were available online, and someone came up with a genius idea. Why wouldn't we take the concept which we use for the virus and make it different? Instead of having everything in one file, we would create a cryptor and then decryptor. And so the cryptor will take executable file as an input, and what it will output is a new file. Which will contain a decryptor and remember, decryptor will be polymorphic, so every time it will be regenerated, a new version of it, and then compressed version of that content of original executable is going to be here. And that new file will not contain any virus technology of infecting other files, and it will actually not contain the cryptor by itself. The only part it's going to contain is a decryptor, which is polymorphic and regenerated on every regeneration of the file, and then encrypted version of the P file with original P. And the reason why it was kind of genius idea from the malware author's perspective is because now you have all these components. So what you could do with that technology is that every time victim gets infected, and let's say either through exploit or through another downloader malware, it queries your web server, your cloud, for the next stage of the malware. Your cloud returns new variant. And it's not just new variant, but it's also polymorphic. And it's not only polymorphic, it also has custom encryption. So every time new malware is requested on the server, it will be generated with a new code using a polymorphic engine. It will have a custom encryption, a custom packing, so it's pretty much impossible for antivirus industry to create a static unpacker for every single packer, because now every day the packer is going to be different. Like the authors of that can literally every day change the generator and the polymorphic engine slightly, so it's pretty much impossible to statically unpack them because every day they're going to be different. And every victim which asks, like where either the exploit or the other downloader malware asks for that to download a next version of your malware, it will receive a new version every time. And that's exactly what you have seen in the previous video about exponential growth, that pretty much no new technology. The polymorphic code already existed. The polymorphic engines already existed. And if you think about this, the server-side polymorphism is actually much more simpler than the virus-based polymorphism, because in virus you had to have encryptor, decryptor all inside the virus. It all has to be position independent code. It has to be small because you had to embed it in a benign file through the infection. Now it was so much easier because encryptor is just running on the server side, the generator of polymorphic code is running on the server side. The only thing which it gets as an input is a binary file, and it outputs encrypted binary file with a polymorphically generated decryptor. And that was a huge revolution in the malware development, and that was a revolution where most of the antivirus companies were not ready for, because at that point signatures were pretty much dead. You couldn't detect anything with the signature on the original file itself. Static unpackers were pretty much dead. You couldn't create a static unpacker for the polymorphic engine, which changes every day or every week. And yeah, that what was the big move from the malware side to revolutionize the packing, and of course that caused the response from anti-malware side to revolutionize unpacking. But that was one of the biggest changes in the period of 2005-2010, which happened in anti-malware and malware industries. Okay, now you know what server-side polymorphism is, and if you're still not quite sure, make sure you rewatch my previous videos about polymorphic code and how polymorphic viruses work. But let's say you understand what server-side polymorphism means. Let me also tell you what it is not, because there is a lot of confusion about this, especially in among the less technical people. And sometimes what people think about when they talk about server-side polymorphism is that when you have a server which when you have a server where every request to download file would have generate a different file hash. And very often when people say, oh, every time download happens, the server side generates a new file hash, so it's a polymorphic malware. And while it's pretty much always the case when the polymorphic download happens, polymorphic malware generate the new variant, it will always have a different file hash. The opposite is not always the case. If you observe a different file hash on every download, it doesn't actually mean it's a polymorphic malware. What might happen is that every time you request a download, it simply compiles a new version of the same source code, and what changes is the compilation date. In this case, malware is not really polymorphic. It's just every time you download a variant, it will be a new compilation, a new date. There's also like this poor man polymorphism, which is not really a polymorphism, where malware would just add a random set of bytes at the end of the file or somewhere in the middle. Again, the code itself, the source code of the malware is the same. There is no polymorphic decryptor or encryptor. There is no polymorphism actually. The only thing it does is randomly generates a few, like a random number of bytes at the end of the file, somewhere in the middle of the file, to change the file hash. And the reason malware does it, because there are a lot of anti-malware technology nowadays which still depend on a file reputation based on the file hash. Remember, we had a video and I told you that the file hash is absolutely horrible idea to detect malware using it. Well, that's why even malware authors who don't have a actual server-side polymorphism, we're using this either recompilation or random number of random bytes added to the end of the file just to simply throw away the file hash-based detection, because every time file would be downloaded, the file hash is different, and anti-malware products which would use file hash for detection would not be able to detect it. That's another reason why file hash is absolutely horrible technology for malware detection.